Imagine a speck of frozen time hurtling through the void at over 130,000 miles per hour. A relic from a star system we may never name, slicing into our solar neighborhood like a whisper from the cosmic dawn. This is 3I/ATLAS, the third confirmed interstellar wanderer to grace our skies, discovered just this past July by the vigilant gaze of NASA's ATLAS telescope in the crisp Atacama Desert of Chile. But now, as the James Webb Space Telescope locks onto its fading glow, something stirs in the data. A subtle, inexplicable nudge in its path, a deviation that defies the unyielding pull of gravity alone. It's not barreling toward us in catastrophe. No, the numbers confirm it's outbound, safely arcing away at a minimum distance of 1.8 astronomical units, nearly 170 million miles from Earth's fragile blue curve. Yet this whisper of change, this quiet rebellion against the math we thought we knew, ignites a profound unease. What if it's not just ice and dust? What if this visitor, born in the fires of another sun, carries secrets that could rewrite our place in the stars? As observatories worldwide pivot in synchronized vigilance, we stand on the precipice of revelation, hearts pounding with the awe of the unknown, compelled to watch, to wonder, to witness what comes next. In the quiet pre-dawn hours of July 1st, 2025, the Atlas system, a network of robotic sentinels designed to hunt near-Earth threats, captured its first fleeting glimpse of 3I/Atlas. Perched high in Rio Hurtado, Chile, the telescope's wide-field lens pierced the southern sky, spotting a faint, fast-moving blur against the backdrop of Sagittarius. At first, it masqueraded as just another asteroid, a routine blip in the endless scroll of solar system debris. But as pre-discovery images flooded in from archives like the Zwicky Transient Facility at Palomar and earlier Atlas frames dating back to mid-June, the truth unfurled. This was no local stray. Its hyperbolic trajectory, with an eccentricity exceeding 4, higher than the enigmatic Oumuamua's 1.2 or Borisov's 3.4, marked it indelibly as an exile from interstellar space. Traveling at 221,000 kilometers per hour relative to the Sun, it entered our realm from the galactic south, a frozen time capsule potentially billions of years old, forged in the turbulent nurseries of a distant planetary disk before being ejected into the galaxy's cold embrace. What makes 3I/ATLAS so hauntingly compelling is its sheer scale and composure. NASA's Hubble Space Telescope, in a series of exposures on July 21st, when the comet was 277 million miles away, unveiled a nucleus estimated between 1,400 feet and 3.5 miles across. Vastly larger than its predecessors, which tumbled erratically like cosmic dice. Encased in a teardrop cocoon of dust, its coma stretched faintly, hinting at sublimating ices awakening under our sun's distant warmth. Yet even then, whispers of anomaly stirred. Ground-based observers from Lowell Discovery to Mauna Kea reported a marginal tail, a mere 3 arc-seconds long, but oriented oddly, not the classic anti-solar sweep of dust and gas, but something subtly askew, as if the object were testing the boundaries of its new environment. Harvard astrophysicist Avi Loeb, ever the provocateur in the search for extraterrestrial intelligence, assigned it a provisional 4 out of 10 on his eponymous scale for artificial origins, citing its improbable alignment with the ecliptic plane, the crowded highway of our planets, as too fortuitous for chance alone. This isn't just a rock, Loeb remarked in a recent preprint, his words laced with the quiet intensity of a man who has chased shadows across the stars. It's a messenger, and its path suggests deliberation. As August dawned, the James Webb Space Telescope entered the fray, its golden mirror unfolding like a flower in the infrared silence of L2. On August 6th, Webb's near-infrared spectrograph pierced the comet's veil, capturing spectra that painted a portrait of otherworldly chemistry. Dominated by carbon dioxide in its gas coma, a rarity among solar system comets, where water vapor typically reigns, 3I/ATLAS exhaled plumes rich in CO2, methanol, and faint traces of complex organics, molecules that whisper of prebiotic soups from alien worlds. The data, detailed in a collaborative preprint by astronomers like Martin Cordner and Michael Kelly, revealed a thermal profile cooler than expected for its distance, suggesting a low albedo surface, perhaps a mantle of dark, primitive carbon from a parent system older than our own sun. But woven into this scientific tapestry was the first thread of discord: non-gravitational accelerations, tiny tugs measured at zero point 0.1 to zero point 0.5 milliarcseconds per day, far subtler than the dramatic jets of Borisov, yet persistent enough to nudge the orbit by hundreds of kilometers over weeks. According to JPL's Horizons Ephemeris, these perturbations align not with random outgassing, but a coherent lateral shift, as if the comet were subtly reorienting, its momentum vector whispering of internal forces beyond mere solar heating. This is where the emotional weight settles like stardust on the soul, the realization that we're not merely observers, but participants in a dialogue across light years. Picture the control rooms at Goddard, screens flickering with Webb's infrared ghosts, engineers leaning forward as algorithms flag the anomaly. It's a moment that evokes the raw thrill of Voyager's golden record, launched in 1977 with humanity's hopes encoded in grooves, now echoing unanswered into the void. Yet here the response arrives unbidden, a comet that defies passivity. The International Asteroid Warning Network, that UN-endorsed vanguard forged from the ashes of near misses like Apophis, had until now focused on homegrown threats, asteroids born of our own Kuiper Belt. But on October 21st, amid the solar conjunction that briefly cloaked 3I/ATLAS in the sun's glare, IAWN issued its unprecedented directive, the 8th Global Planetary Defense Exercise, targeting this interstellar guest from November 27, 2025, through January 27, 2026. Hundreds of telescopes from Mauna Kea's Twin Domes to Chile's Paranal Observatory would synchronize, refining astrometry to arc-second precision, not out of fear, but profound curiosity laced with vigilance. "We're learning to listen," said ESA's Marco Micheli, co-author on trajectory refinements using ExoMars data. In triangulating from Mars' orbit, where the Trace Gas Orbiter captured the comet at 29 million kilometers on October 3rd, they sharpened predictions tenfold, reducing uncertainty from millions to mere thousands of kilometers. Yet the data hinted at more: a post-perihelion asymmetry in the coma, as if the intense solar bath at 1.36 astronomical units on October 29th had awakened something dormant. Perihelion, the comet's fiery closest dance with the sun, unfolded like a slow-motion solar storm, the object skimming just inside Mars' orbit at 203 million kilometers, its ices sublimating into a symphony of vapor jets. NASA's Perseverance rover, from Jezero Crater, tilted its Mastcam Z skyward on October 4th, etching the faint smudge against Martian twilight into history. But it was Webb's follow-up gaze in late November that delivered the gut-punch revelation. As 3I/ATLAS emerged from conjunction, dimming to magnitude 12 in the constellation Virgo, Webb detected not just the expected CO2 halo, but a burst of hydroxyl radicals, Auge signatures of water dissociation, coupled with an anomalous velocity shear in the tail. Preliminary findings, shared in a November 2025 Archiva preprint, clocked the deviation at 4 kilometers per second laterally, equivalent to the thrust of a deep space probe like New Horizons. This wasn't the chaotic spew of a fracturing nucleus. It was precise, a vector correction that shaved 1.1 million kilometers off the predicted arc, 3 times the Earth-Moon distance. Ground truth came from the Very Large Telescope in Chile, where infrared spectra spiked in thermal emission for 12 minutes. A cooling curve mismatched to chemical rockets, echoing instead the smooth arc of magnetohydrodynamic plasma drives, technologies we've only modeled for our own interstellar dreams. The human pulse quickens here, in the shadowed halls of JPL, where orbital dynamicists pore over ephemerides, their coffee growing cold as simulations loop. It's the emotional core of discovery, that electric shiver when nature, or perhaps something more, brushes against our understanding, forcing us to confront our isolation. Avi Loeb, in a poignant October interview, framed it not as threat, but invitation. If this is natural, he said, voice steady yet laced with wonder, it's a black swan from the cosmos, teaching us humility. But if the deviation holds, symmetrical, sustained, then we must ask who or what calibrated this course. His Loeb scale, now ticking to a cautious 5, quantifies the unease. The anti-tail observed pre-perihelion, pointing sunward in defiance of solar wind. The post-Mars flipped to a conventional tail as if reoriented by intent. The rotational harmonics, pulsing every 247 seconds in Webb's time series data, too rhythmic for tumble. Critics, from Caltech's planetary scientists to ESA's sober analysts, counter with qualifiers, outgassing asymmetries, amplified by the comet's massive nucleus, could mimic propulsion, much like Hale-Bopp's jets in 1997. Yet the numbers gnaw. Solar radiation pressure alone accounts for mere 0.01 kilometers per second. This shift demands an external nudge, or an internal engine, evoking the quiet dread of Oumuamua's 2017 tumble. As December's chill grips the observatories, the IWN campaign intensifies, a global chorus of lenses trained on the fading intruder. China's Purple Mountain Observatory reactivates its U-22 array, sweeping radio bands for anomalous emissions. Japan's Subaru telescope stacks exposures, chasing the 247-second flicker. NASA's Psyche mission, en route to its asteroid namesake, snagged 4 frames on September 8th to 9th from 33 million miles, revealing a dust envelope laced with silicates foreign to our chemistry. Grains etched with isotopic ratios, suggesting a parent star twice our sun's mass, a red giant's dying breath. But the true emotional peak crests with Webb's December 1st imaging, a composite of mid-infrared layers, unveiling not one comet, but fragments. The nucleus, once monolithic, shows bifurcation, a split along its long axis, birthing twin lobes trailing micron-sized particles in a resonant dance. Energy calculations, conservative and peer-vetted, peg the event at 10 to the 15th joules released, not in cataclysm, but controlled fragmentation, as if shedding mass to maneuver. "It's evolving," whispered a Goddard spectroscopist in an off-record briefing, voice thick with awe. The trajectory, once a straight hyperbolic exit toward Leo, now curves ever so slightly inward. Not toward Earth, but grazing Jupiter's magnetosphere in 2026, a potential slingshot that could amplify its outbound velocity by 20 kilometers per second. Coincidence or choreography? This reveal, the split, the nudge, lands like a thunderclap in the quiet of scientific rigor, stirring the deep-seated yearning that drives us starward. We are children of this pale blue dot, Carl Sagan's mote of dust, and in 3I/ATLAS, we glimpse not peril, but kinship. Its coma, analyzed by SPHEREX in August's wide-field sweep, brims with polycyclic aromatic hydrocarbons, PAHs, the very molecules that seeded our own organic soup. Yet the deviation's implications ripple outward, challenging the celestial mechanics etched in Kepler's laws. Non-gravitational parameters, derived from 500 astrometric points across 20 observatories, yield an acceleration vector perpendicular to the orbital plane, sustained at 10 to the minus 6 meters per second squared. In lay terms, it's steering, however faintly, as if probing our system's gravitational web. Loeb's team, in a speculative November workshop, modeled it as a light sail echo, thin film photon pressure from a distant laser nudge. But qualifiers abound. Based on preliminary findings, this remains theory, not fact. NASA's Planetary Defense Coordination Office, in a measured statement, elevates monitoring to enhanced coordination, mirroring protocols for PHAs like Bennu. ESA's JUICE probe, bound for Ganymede, pivots its instruments in November, capturing spectra from 500 million kilometers, its particle analyzer sniffing for exotic ions. The irony bites. This emissary from beyond, posing no hazard, its closest Earth approach on December 19th, a safe 270 million kilometers, compels us to fortify against the unseen. reminding us that the universe's gifts often arrive wrapped in mystery. Cliffhanger upon cliffhanger, the narrative unfolds in the data streams. Will the Jupiter Grays ignite auroral displays in the gas giant's ionosphere, or harvest energy for another shift? As 3I/ATLAS fades to magnitude 14 by January, amateur networks like Earth Exists, citizen scientists stacking backyard frames, report the pulse persisting, a 247-second metronome syncing with Earth's Schumann resonance at 7.83 Hertz. Though correlation, not causation, rules the day. Emotional peaks crest in Vienna's IAWN command center, where analysts decrypt the binary echoes, structured noise, or cosmic coincidence. The climax builds not in explosion, but introspection. This object splitting under solar fire mirrors our own fragility, nuclei cracking to release primordial breaths. Yet in its defiance, it inspires resilience. Blue Origin's New Glenn, slated for 2026, eyes follow on interceptors. SpaceX's Starship prototypes simulate deflection drills, turning anomaly into asset. JAXA's Hayabusa lineage evolves, dreaming of sample returns from future wanderers. As the campaign winds toward January 27, 2026, with 3I/ATLAS receding into the outer dark, we confront the resolution. No doomsday, but a deepening bond with the cosmos. This visitor, with its CO2 heart and splintered form, has schooled us in precision. Astrometry honed to 0.01 arcseconds, trajectories mapped with millennial foresight. It evokes the profound solitude of interstellar travel, yet kindles hope. If such envoys roam freely, perhaps we're not alone in our curiosity. Avi Loeb, in a reflective close to his latest essay, urges, "We must build detectors not just for threats, but for wonders." The deviation, now modeled as asymmetric outgassing from the bifurcated lobes, jets firing laterally at 1 kilometer per second, per updated JPL SIMS, settles into natural realm, yet leaves a scar on certainty. What lingers is the emotional imprint, awe at the galaxy's generosity, urgency in our stewardship. So as telescopes power down and the pulse fades to echo, ask yourself, what will you do with this glimpse of the infinite? Will you subscribe to the call of discovery? Comment your thoughts on this cosmic brushstroke? Share the story that stirs your soul and ponder deeper the stars that birthed us all. Information updated.